It is getting to that time of year again to start thinking about doing more refrigeration related projects. So this year it's a thermostatic expansion valve that I got, and I'm going to be greatly improving the hot tub heater. I've also ordered a refrigerant to water heat exchanger for it, a massive plate heat exchanger. And I wanted to use a thermostatic expansion valve to see if I could improve its efficiency and make it easier to operate. So this year I got it for it was £13 in total. That's including the postage. So that was a decent price. I've been looking at expansion valves before and they're just all too expensive. So what we have here, this one is for R22, but unfortunately I've only got R290. But I was reading that some expansion valves actually use a different refrigerant in the bulb from what the system uses. In some cases that actually improves the performance, but for R290 I don't know if it's going to work. So if it doesn't work, what I could always do is cut this bulb off and make up my own bulb with just a little bit of R290 in it. But the way it works is there's obviously some amount of refrigerant in here. I'm not sure if it will be R22 or not. But that just basically goes on the outlet of the evaporator, this side's on the inlet, and it basically just tries and maintains a constant superheat. And you adjust the superheat by turning that screw in there. But I have honestly no idea if this is going to work. This expansion valve can operate from, it said here, here's some information, -45 to +20 degrees C. I'm not exactly sure how you would adjust the temperature that it operates. It only lets you adjust the superheat as far as I know, but maybe adjusting the superheat is adjusting the temperature as well, so it shouldn't be too much of a difficulty. I think when I install it, what's going to happen is it'll probably do what's known as hunting, where it keeps changing the superheat up and down, and it never actually finds the right superheat. But I can't be sure really. I'll just have to try it. The bulb I'll mount to the return from the evaporator, but I'll use a thermal compound for that. This is how it would normally be mounted, but I'll put a bit of thermal grease on that. So it's got a flare fitting on here. That's the outlet hole. So, and on the bottom it's the exact same flare threads as that, but it's not a flare fitting, so I don't know. I think I should just solder a bit of copper tube in there and then just wrap cold wet cloth around the top just to stop it getting damaged with the heat. I'll probably just solder to it. I'll probably just solder on there as well. It should be okay. This is the heat exchanger that I got. The threads on there are roughly 20mm, but the flare fittings are different sizes. So I think this is a 1/2 inch flare. I can't remember the sizes exactly, but this one is 1/2 inch, and I've already made a flare up for that, which I'll mount to the heat exchanger when it arrives. And this one is 3/8, so I've just got to make up 2 flares for that, and then it'll be good to go, hopefully, if they seal well. My 2 old exchangers, I did a calculation, the exchangers that are currently on the heat pump, it's only about, I think it's 0.2 square meters of exchange area. This has 0.9, I'm sure, 0.92 square meters of heat exchanging area. So the refrigerant coming out at the discharge coming out will be roughly about the same temperature as the water, not a fair bit hotter, as has been the case with the current exchanger. It'll make it much more efficient, and thus the refrigerant coming back into the evaporator will be colder, and it'll be able to move more heat from the air as a result. Okay, something has just occurred to me. This actually won't work at all. because it's just it's like it's just a straight sort of hole through there. I'll see if I can get light to shine through it. But yeah, it's just basically sort of like a straight hole through. It's like there's an extra piece that's meant to be screwed onto this bottom bit here, which I don't have unfortunately, so this isn't going to work unless I can find what part actually goes on there, because it's just a straight hole through. Like, you could just blow straight through it. There's nothing there, it's just sort of a pin. The air just goes right through it, so I'm going to have to try and find what part that is.